Okay, so I've gotten a couple of emails about some of the homework questions that are due on Wednesday, I believe it is. And I wanted to go ahead and make sure that we work some of those out. There is information in the chapters in the book about how you would handle halves. I didn't cover much about that in class in my lecture video. However, I did tell you to go ahead and read it. So I think it's on page 15 and page 16 in the book. So like here's page 16 right here. It says, that you're basically working like an Egyptian here. And this goes along with number 3 in the homework. So you're working like an Egyptian. They're doing groups of 12. They doubled it again. They got 48. And they wanted to, I don't remember what problem they were working on here. It looks like they're doing 4 1/4. Oh, apparently they're trying to get to 51 is what they're trying to do. So they know that they can come up to 48 by doing 4 groups, but then they need to also get to 51, which if I'm doing a group of 12, clearly I don't need another group of 12 to get to 51, right? 48 plus 12 will get me to 60. So then they start doing halves. And there's some proof in some of the papyri that the Egyptians seem to be able to do halves really well, or if the number was a number that's like a multiple of 3, they could divide by 3 pretty well. So instead of thinking take a half of, they would think, well, let's divide, right? But so here if they were doing groups of 12 and they wanted a half of a group, they would take the 12 and divide by 2, right? So they'd get a 6. If they wanted a fourth of a group, then they would want to take half of a half. So that's really important that you're taking half of a half, because I've already got the half is 6. So if I take half of that again, I get a 3. And if we were trying to get up to 51, which is what this problem was wanting me to do, then it would be 48 plus 3. So they would keep on doing this halving or something like that until they got the extra number that they wanted to add, which in this case was 3. 48 plus 3 gave them 51. And then they would know, well, that was 4 groups and it was 1/4 group, so I want those 2. That's what this little symbol in this particular book by Dr. Anderson means. So they wanted the 4 and the 1/4. So that's what's going on in your book on stuff like this. It can also be applied to division, although you don't have a homework question on that. A similar process can go. So let me say, what if we were dividing 75 divided by 30? And I asked you to do this like the Egyptians did it. So one group of 30s would be 30. 2 groups of 30 would be 60. 4 groups of 30 would be 120. Clearly I don't need that because I'm only going up to 75. So I would stop there, but for sure I'm going to need 2 groups of 30 is 60. Okay. I don't need 2 groups of 30 plus 1 group of 30. That would be 90. Again, that's too big, right? So I'm not adding those. So they realize that they need a partial group is what's going on here. So in this case, I actually would know I have 2 groups with 15 remainder, right? 2 remainder 15 is the way we would say it with young kids or something, okay? So real quickly, I can look at one group of 30 and say, oh, well, 15 is half of that. So a half of a group of 30, that's what we're after here, would be 15. And then I know 60 plus 15 adds up to 75. So clearly it was 2 1/2 groups. So 75 divided by 30 is 2 1/2. And so sometimes the Egyptians would do problems like that, and they don't need to deal with decomposition of fractions or anything like that. They just need to realize that 15 is a half of a group of 30. So they would work those kinds of problems out. And there are problems in different papyri, I guess, that papyruses, I don't know what that would be, plural. But anyway, there are problems where they're doing things like that, and they clearly understand that a half of 30 is 15. They could also do groups of 1/3, right? A third of a group of 30 would be 10. As long as the number will go in nicely. What you're probably not going to see for 30 is you're probably not going to be seeing them say, well, take, an eighth of a group or a seventh of a group, because those don't go in nice and pretty, right? So if we're doing fractions of groups with the Egyptians, we're probably doing fractions of groups that come in very nicely. So with that in mind, I want to look real quickly at number 22. Oh, I'm sorry, page 22, number 3. Because that's the question I've gotten the most emails about. So, and I emailed a couple of you back and said, I'll get to it. I'm just going to do a video for the whole group. So thank you for waiting. I know some of you have been patiently waiting for this video to come out. So here we go. Page 22, number 3. I think the first problem that people are having with it is just the distribution property. Okay, which we're going to do distributive property just like we would in modern mathematics. So let's start with I'm not going to work all of these out. I just want you to see what's going on. This is, I'm going to put the 37 in the front. 37 times 11 plus 1/2 plus 1/8. So yeah, you're just going to do this just like a regular distribution property, but you're going to do it like an Egyptian, right? So 37 times 11, plus 37 times 1/2, plus 37 times 1/8. And so you're distributing. Okay, that's fine, no worries. Okay. We've got 37 times 11. We'll do that by the doubling method. So you'll take this off to the side and you'll do one group of 37. Well, that's 37. And two groups of 37. And figure out what all of that is until you figure out 11 groups. So that's going to be just like you're used to with the Egyptians. That's nothing new. But this one's a little bit of a pain for me because it's a half of a group of 37. And I just got finished saying they're probably not going to do a half of a 37 because that's not likely to come out nicely, and then they gave you this one in the book. But we can still do it. It's just a little bit of a pain. So what you would do is a half times 37. Okay, they can do that pretty easily. What is that? I haven't even prepared that. It looks like 18.5 to me. Okay. But the weirdness comes in here for the 1/8. I think that's what's bugging people. So to do this like Egyptians would do it, the half is pretty straightforward. But the Egyptians wouldn't have then turned around and said 1/8 times 37. Think about that doubling idea and think about what we can do here. We're taking a half and then we're trying to get to an eighth. So next we're going to do a half of a half, right? So 1/4 times 37 would be take this guy and take half of it. Well, 18 divided by 2, I can do that as 9. 1/2 divided by 2, I can do that as 1/4. Or you could think of it as multiplying by 2 in the denominator, however you want to think about that. This one happens to work out pretty nicely for me. The next one's not going to be so nice. So if you want to make these into improper fractions, I know some people really like that. You would do 37 over 2, and then you would do what? 10 over 4, and so on. You're very welcome to do that. That's fine. So if improper fractions is nicer for you, then go for it. But to get to the 1/8, I've got a half. Remember, this is a half of a half. And to get to the 1/8 times the 37, that would be what? In my head, I'm hearing a half of a half of a half, right? So literally just taking a half of the group on top of above it, right? So here, the problem here for me is if I do it with the 9, taking half of that now becomes not pretty because it's 4.5. And then the 1/4, I can make that be an eighth, sure. Okay, and then I'll have to do something with the denominators or whatever. Maybe I like that as an Egyptian because quite frankly, those are nice, pretty unit fractions. So maybe I would do it that way. But for purposes of if you were doing this and you had 10/4 times 1/2, that becomes easier to deal with, right? Because the 10 will reduce with the 2. And now you've got 5/4. Okay. So hopefully we've got something like that going on. Oops, did I mess something up? Hang on a second. 10/4. Yeah, what I messed up. Nobody said anything to me. What I messed up was up here. I'm sorry. This was silly of me. 37/4. So this would be 37/4 times a half, which will not reduce. That's the problem. Which is 37/8. Sorry about that. All right. So either I would take the half of the half of the half, or if you were working with improper fractions, see, I wasn't the improper fraction girl, so I was trying to say you could do that, and then I got distracted. So, okay, so yeah, 36 plus 1, right? Yes, okay. Just double checking my math since there's nobody in here today to correct me. Okay, so that's the idea behind 3A. That's the only one I'm going to work all the way for you. So think about that. Well, and I didn't even work this piece over here, but you can get there. I know you can. But the other ones are the ones that were bugging people. So let me say, like for instance, 3B. I would do a similar process, but I would do them one at a time. But notice that they're giving me, and people were like, oh, there's so many fractions when they were emailing me, I know. But it's not really that bad whenever you look at them because they're all halves and fourths and eighths, right? So when you think of that halving and then halving a half, it's not as bad as what you might have thought to begin with. But I would still start with the distribution, right? So one group of nines, one group of halves, one group of fourths, okay? Figure out what that looks like for Egyptians. And I saw on the discussion board where somebody was asking, do we need to then turn around and write our numbers in Egyptian numbers? No, we're not doing that. The only time that I'll want you to write your numbers in Egyptian numbers, I will actually say, like, leave your answer in Egyptian hieroglyphics, or use this, and I'll have the little emblems off to the side, the symbols. Use these hieroglyphic symbols to do such and such math. So that's the only time I'll do that. So you don't have to stress out about that. I'm never going to do something weird to you like that. If I want you to do something other than in base 10, I will tell you, like, you know, your book talks about sexagesimal, which is base 60, right, which is Babylonians. So that'll be clear, or if it's not with Hindu or Arabic numbers, it'll be clear. It'll say use these Greek letters or whatever. So be obvious. Okay, so then you would do a half of a group of 9, a half of a group of a half of a group of 1/4. Okay, and this will take a little bit of time to do it this way, and I hope that what you're seeing as you work through some of this stuff is, man, those Egyptians, they had it rough, right? Okay, so let me finish this out. A fourth times a 9, a fourth times a half, a fourth times a fourth. So this is a half of a half of a half, right? So that's going to end up being an eighth. So you'll work those out. You'll do these as groups of 9, that kind of thing, just like the Egyptians did. They're just kind of a little bit more in depth. And I think the point for this particular textbook, they tend to do a little bit of weird stuff out there. I think the idea is that you guys are grad students, and so you should be able to take this just a step farther than what we would do with, say, our 426 math class, which is math history for math majors for the undergrads. So being able to do just a little bit more with this kind of stuff. I also saw one little question on the discussion group about what the heck does this stuff mean, the parentheses and all that, 4, page 51, and there's some stuff where it says page X and stuff like that. If you'll remember, I said on the first class day, Dr. Anderson is the one who wrote this textbook, so he's given it to us for free, which is yay, for free. But the bad side of that is it's still not completely hammered out everything. So whenever he has references, those are normally to the Burton book. You could probably look at Burton 7th edition. I think it's like history of mathematics, student's approach, or something like that. I can get you the information if you really want it. But so any of those are probably referring back to the Burton book, because that's the person that he collaborated with to get us this textbook. So that's what's up with that. Now you know. All right, one more question on homework, and then we'll get into the actual content for today, and I'll make a new video for that. So if you don't want to watch these questions, you don't have to. Somebody asked me about number 4 on page 22, which number 4 says, okay, first prove this thing. Okay, we're actually going to do a proving thing today, so if you're not sure about that, hang on, because we're going to play with it. But you're mostly just working on the right-hand side, right, to make that something that I would get a common denominator and then simplify it as much as possible, and hopefully it falls out and looks like the left-hand side. So to me, it is a proof, but it's more of a trigonometric identity kind of proof. It's not like discrete math hardcore proofing class, right? So it's not the same as that. And then it says, though, next use this formula, the one you just proved, use that formula in a spreadsheet to reconstruct the Rhind Papyrus fraction. So first of all, spreadsheet, in general, I think of Excel, but if you're a Mac person, there should be some way to make your file be Mac or be PC friendly once you've played in, I think that's Sheets, right? I don't know what that version is in Mac. I think it's called Sheets or something like that. But anyway, make it look like an XLS file and then save that and load it up. So that's what you're going to do for that. But use that formula. So for instance, if n is 3, which should be the smallest 2 over n fraction in the Rhind Papyrus was the 2 over 3 guy, right? So if n is 3, then this particular formula, plug in a 3 everywhere you see n, should give us a unit fraction decomposition for 2 over 3. Now, it may not be the same one as what's in the Rhind Papyrus. Not exactly, that's okay, but it still gives me a unit fraction decomposition for 2 over 3. So then you'll go to the next row and use n equals 5, n equals 7, n equals 9. So there are some shortcuts for getting that done. For instance, getting the spreadsheet to add 2 each time. So you could have one column that was n equals 3, n equals 5, n equals 7, blah, 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 and figure out how to make it add all the way up to 101, because that's how big the Rhind Papyrus goes. Okay, so you can do that for the 1, and then putting this formula into, if you really know how to use formulas in Excel, you can do it in one cell, C-E-L-L, cell. You can do it in one cell and have it just pick it up and tell you what that's going to look like. If you don't, if you're not really good with the formulas, then you might want to do one column for 1 over n, one column for 1 over 2n, one column for 1 over 3n, one column for 1 over 6n. Now, the trick to this is getting Excel not to, for instance, if it's 1 over 6 times n, that's 1 over 18. I want it to leave that in fraction form, right? So there's a way that you can play with the text, okay? It's like a right click and cell format or something like that to make sure it leaves it as a fraction rather than a decimal, okay? So you're going to want to do that in order to get that to happen. And then you can either just add each of those cells up, or you can have one cell that does all the adding for you, that kind of thing. But when you're finished, your final column should look like, in this case with the 3 guy, let me finish that, 1 over 3 plus 1 over 6 plus 1 over 9 plus 1 over 18. Okay? So you should be able to do a recreation of that. Now, that's not what the actual Rhind Papyrus says for 2 over 3, but it is an equivalency, so we're good. Okay, and when you're finished, you will actually upload that spreadsheet into D2L. I think it takes Excel files. I'm pretty sure about that. If you have an issue, let me know. I think I had somebody put me some Excel files last semester. So I think that's about it for what questions I had on the homework. I hope that helps you. That set is due on Wednesday, so good luck with that. I'll be right back with content. Yay.